Hello everyone. Today we are discussing about time series forecasting using profit. Before we dive into this topic, let us first understand what is time series. A time series is a sequence of data points recorded over time at regular intervals. This is useful to understand how a value changes over time. Now let us see what is time series forecasting. Predicting future values based on the previously obtained data points is known as time series forecasting. Now, let us understand about Profit algorithm. Profit is an open source time series forecasting tool developed by Facebook. It is designed to provide accuracy. This handles missing values, outliers, and seasonal variations well. It is an additive regression model, which means, as we can observe in here, hmm, it is dependent on the trend, seasonality, and holidays. Trend represents the long term upward or downward motion, whereas seasonality represents the pattern like daily, weekly, and yearly. Holidays or events represents outliers or special events. Here, to understand the time series forecasting using Profit, I have considered a sales data set that consists of a date column, the product, the store, and the value. Here, we are trying to forecast the value, which is like the total value obtained from that product sales. Here, we are installing the Profit. Next, we are importing libraries like pandas for the data frames, Profit, and Matplotlib for the plotting. Next, we are loading the data set. Here, we are extracting the columns year, month, and date from the time column, and we are creating a new column named DS, which consists the date time in the time format, which is necessary for the forecasting. Here, Mm, we are filtering or we are forecasting for a particular product and a particular store. Now, we are implementing the profit model by initializing the profit model by fitting the model to the data set. And then here we are creating 100 data frames for the future data. Next, we are predicting the future data by using the profit model. And now here, as you observe, YHAT is the predicted model, predicted value, and the lower and the upper are the confidence bounds. And here we are plotting the graph for this predicted forecasting model. And we are also plotting the components of the model. Now let us observe the data forecasting. So here, all these black dots represent the actual data points. The blue line represents the prediction, and this indicates the lower bound, and this indicates the upper bound. Here we have taken confidence level of 95%, which indicates that 95% of the data points will lay inside the confidence bound, and we are predicting for the next 3 months. We have data till December 2020, and we are predicting the future values for the next 3 months. Now, observing the trend, here we are observing the monthly trend, and it is showing an upward trend. And here, when we observe the weekly trend, it is showing that there's a dip in Tuesday and Friday, which indicates that this is contributing to lowering the value of the predicted value. And for the yearly trend, we observe that there is a major upward trend since the months May to November. And when we observe the daily trend, we do notice that most of the sales happen during midnights. Now, moving forward, we can also calculate the cross validation. Here, to calculate the cross validation, I have initialized for the to take 365 days of data across the horizon of 180 days, which indicates that I am calculating for the next 180 days. I'm predicting for the next 180 days. And the period is 90 days, which means that the whole process is retrained, the whole model is retrained for every 90 days. Here we are plotting a cross-validation matrix based on the root mean square error. On observing this graph, we observe that around 50 and 130, we observe that the root mean square error is high. Here, the blue line indicates the smooth general trend of the root mean square error, whereas these dots indicate the individual root mean square error for that particular horizon. Thank you.